In this video, we're going to estimate the volume of a solid using a double Riemann sum. So we're given the function z equals 1 plus x squared plus 3y, and are told that it lies above the rectangle 1, 2 cross 0, 3. So 1, 2 are the possible x coordinates, and 0, 3 are the possible y coordinates that are in this rectangle. It asks us to use a Riemann sum with both m and n equal to 2, so 2 subintervals for the x direction, 2 subintervals for the y direction. And first, to choose the sample points to be the lower left-hand corners. And then in part B, asks us to use the midpoint rule to estimate the volume rather than the lower left corners to estimate. All right, so since we're using 2 intervals in the x direction, the length of each subinterval will be 2 minus 1 over 2. So we're using that b minus a over n idea to calculate delta x and delta y. So the length of the interval is 1. We want 2 subintervals, so each subinterval has a length of 1/2. Likewise, if we look at the length of the interval for y, 3 minus 0, so the length is 3. Divide that into 2 subintervals, and we get 3/2 for our delta y. So you can see the grid that I've formed here in the picture. They ask us to use the lower left corners of each sub-rectangle for our sample points. So I've marked those here, 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 and here. The other ones are for the midpoints, and we'll do that in part B. But we see the lower left-hand corners are this one and this one, this one and this one. So we can see those coordinates are 1, 0, and 3/2, 0, and then 1, 3/2, and 3/2, 3/2. Those are the points that we're going to plug into the function and use as the height of the box, the little approximating box for the volume of the solid. And then, of course, we have to multiply by the area of the base. Well, the area of the base will always be given to us by delta x times delta y. So notice here, these 4 terms in the sum are taking our sample points and plugging them into the function. I've factored out the delta x and the delta y because each individual term there will get multiplied by delta x times delta y. So there we got 4 approximating boxes that we're calculating the volume of. If we do that computation, you should get 117 over 8. For part B, it asks us to use the midpoint rule, or said a different way, we're going to use the middle point of each subrectangle as our sample points to plug into the function. So for each subinterval, we'll find the midpoint for the x and the midpoint for the y, and that's the point we'll use. So here we have 5/4, 3/4. Here we have 7/4, 3/4. Here we have 5/4, 9/4. And here we have 7/4, 9/4. And again, we're getting the 5/4 and 7/4 from the midpoints of the x subintervals, and the 3/4 and the 9/4 as the midpoints of the y subintervals. But just like we did in part A, we're going to take these 4 sample points, plug them into the function. That gives us the heights of those approximating boxes. Multiply each of them by delta x times delta y. And again, if we do all that computation, we should get 375 over 16.